we look at introduction to series and sequence. Now this is the note I have prepared for you. I will attach this note to the to end of this particular tutorial. The first thing is that let's define what sequence and what series is. Now a sequence is an arrangement of any object or a set of numbers in a particular order followed by some rules. It means when you arrange a number, let's take for example, let me give you some, let's assume we have something like this. Let me clear this thing. Let's assume they give you a number like this. They just said 2, 4, 6, 8, 10. And they give you another one. Let's say another one, they give you 3, let's say 3, 6, 12, then you have 24. Now these are sequence of numbers. There is a rules that guide this one. It means you are just this is 2. It means they multiply this by 2 to they added 2 to this making 4, added 2 to this making 6, added 2 to 6 making 8, added 2 to 8 making 10. Look at the second one. This is also a sequence of numbers. This is 3. You added 2 to, you multiply it by 2. 3 times 2 gave 6. 6 times 2 gave 12. 12 times 2 gave 24. So that is what sequence is talking about. Now let's move on to our question. Now denote by times of those A are just numbers I represented with. Now I said a sequence can be defined based on a number of terms. The number of terms, they said it's either finite sequence or infinite sequence. What do they mean here? It's talking about this one here. This first one is first term. This is second term. This is third term. This is fourth term. This is fifth term. It means this is the first number, second number, third number, fourth number, fifth number. Now if I now said, okay, write an even numbers for me to infinity. Even numbers, you know, it can be even numbers. We have 2, we have 4, we have 6, we have 8, and so on and so forth. So this one is a sequence of infinity. That is, it does not have ending. But this one is finite. Maybe they said you should write an even number between 2 to 10. It means this sequence is finite number. It has ending. So that is what that is talking about. Now we now move on. And I said then I said note what the series is finite or infinite, depending if the sequence is finite or infinite. Now that goes to what a series. A series is defined as the sum of elements of a sequence. It means when you add up all the elements of a sequence, you have a series. A sequence are those numbers, the rules they give you in that number. They may ask you, okay, right? Then somebody may write 3, 5, 7, 3, 5. Let's say somebody can write something like this: 3, 5, 7, 9. You can see when you look at this number, there is something that is common here. It means the person added 2 to this 3, making 5, added 2 to 5, making 7, added 2 to 7, making 9. Now this is a sequence of number. Now when you now add all this number up together, 3 plus 5 plus 7 plus 9, this make a series. This is a series of numbers. So I hope you understand the difference between a sequence and a series. Now we'll move on. That's the difference between a sequence and a series. I will attach this note to this particular tutorial, so you have the notes and you take a glance through it, so you have a basic concept and basic understanding of sequence and series. Now the first one says set of elements that follow a pattern. It must follow a pattern. You cannot write what that means is that if I write 1, let's say 5, and I write 8 here, this is not a sequence, because when I added 4 to this one making 5, and I added 3 to 5 making 8, let's assume and I add another one, I put 25 now. This thing does not, you can't get a number for the second one because it does not follow a pattern. It must follow an order. Maybe the first one you must add 2, the second one add 3, the third one add 4. Or they may say the first one first one multiply by 2, second one multiply by 3, the third one multiply by 4. So those are what they call following a pattern. Then the series is the sum of elements of the sequence. That is when you add up all the numbers in the sequence, you get a series. Order of elements is important. In a sequence, the order must be important. Order of elements is not so important. That is, in a series, So far you have gotten the sequence of the numbers, you can add it anyway. You can add them, mix them together, add them all together, you still get the same answer. So that is order is not what is not important in series. But the sequence, the order is very important. When you mix the order, the first number, you write the first number, instead of writing the second number, you place the last number at the second place, then it means you have the sequence is no more a sequence again. It has become something else. Now finished sequence, yeah, we have finished sequence, we also have finished series. I told you that finished sequence means a number that has ending. That infinite means does not have what ending, and so on and so forth. And we now move on. That said what types of sequence. Types of sequence and series, we have arithmetic sequence, we have geometric sequence, we have harmonic sequence, we have Fibonacci numbers. These are the types of sequence and series. Types of sequence and series. So let's now look at, in this tutorial, we're going to look at only the arithmetic and geometric sequence. The other one, your teacher will explain that to you when you get to a higher level. But the basic one in ss2 is arithmetic sequence and geometric sequence. Now in this particular tutorial, I'm just going to take you only arithmetic sequence. Now what is arithmetic sequence? A sequence in which every time is created by adding or subtracting a finite number to the preceding number in an arithmetic sequence. Now, I told you earlier that I will just only explain this arithmetic sequence. As time goes on, I will explain the other one. Now, we have geometric sequence, we have harmonic sequence, Fibonacci sequence, and so on and so forth. So, the arithmetic sequence, let me just use this, let me explain that to you. Now, what arithmetic sequence is talking about is that if you are given something like this, let's say you are given 3, let's say you are given 3, 6, you have 9, you have 12. When you check, there's a common difference in between these numbers. 6 minus 3, you have 3. They added 3 to this 3, making 6. 3 to 6, making 9. 3 to 9, making 12. This is what arithmetic progression. Let me not shock you. Let's assume we have another. We have 3, we have 6, we have 12, we have what? We have 24. Now, you know that we multiply 2 times 3, you get 6. 6 times 2, you get 12. 12 times 2, you get 24. But this is not an arithmetic progression. Reason being that the difference between them, when you check the difference between 3 and 6, it is 3. 6 and 12 is 6. It is not the same thing. In arithmetic progression, the difference between the second number and the first number must be the same. The difference between the third number and the second number must be the same. That's it. But this number here is a sequence of number, but it is not arithmetic progression. Now, this one is the arithmetic progression because when you check 6 minus 3 here, you get 2. 9 minus 6, 6 minus 3, sorry, you get 3. 9 minus 6, you get 3. 12 minus 9, you get 3. So, the common difference between them is 3, 3, 3. So, that is what arithmetic progression is talking about. Now, we have another one, which is what? What is now this progression? I made mention of progression. So, let's now explain what progression is. Using our notes, we said a progression is a special type of sequence for which it is possible to obtain a formula for the nth time. Which means that for this progression now, this one I can get what the fifth number will be. Now there's a particular formula we use for arithmetic progression. I'm still going to take you that. I'm just introducing you to basic concept of arithmetic progression and what is different between series and sequence. So in our next class, we are going to look at this arithmetic progression, how to obtain formula on it, and so many things under arithmetic progression. So let's move on.